So we're looking at this, and does this kind of make sense? Like, as I look at it, sometimes math problems that involve percents are kind of tricky because you know how many different ways we worded them on that sheet, right? Remember the sheet that we did? And it said, what percent of 14 is 250? Well, 80 is what percent? And before we kind of learn that nice, easy trick about the is over the of, where things kind of jumbled up in your head a little bit, okay? So, these questions are everywhere. The foolproof way is to do problems with an equation. So I'm going to kind of show you where we're at today. Learning target number 2 said, I want you to solve these percent problems, except I want you to solve them with a proportion. So guess what? We're solving the exact same problems. And by exact, I mean, guess what your assignment's going to be? These exact same numbers. Except you don't get to solve a proportion to solve them today. Today you're going to set up an equation. So you get to vote by the end of the hour today which way you kind of like better. And the cool thing is about math is there's so many different ways to solve problems. So you'll be able to know how to do it as a proportion, as an equation. And from that point on, after the quiz on this, whenever you see a percent problem, you do whichever way you like. Got it? Okay, so I took a vote in third hour, which way people liked better, and it was about half and half, like almost as right down as the middle. So about half liked this way. So let's start to kind of take a look at how we would do this, okay? So let's zoom out on this. To write, nothing to write right now. To write an equation, you must translate from English sentence into an equation, which is a math sentence. I want you to think about languages. There's a Spanish class here, right? Maybe some of you will have it next year. Yep. And when Mrs. Meeks teaches Spanish, she teaches her kids to translate from English into Spanish, right? Hola, ¿cómo te llamas? That means hello, what is your name? So English is a language, and it's for the one we know best. Spanish is a language, and math is a language. Math is a language that uses not words, but numbers and symbols, right? So we're going to translate from English into math, okay? So everybody needs to be paying attention, all right? So we're taking notes and paying attention. So here's how we translate, okay? See this crazy, creepy lady? When you see the word what? When you see the word what, you are going to replace it with a variable. Let's just use X. Or you know what? Might be a better variable to use, and you're going to see why. Maybe A or maybe N is going to be a good variable to use. You'll see why in a minute. Because that is the unknown that we're looking for, right? So when we see the word what, we're going to put a variable. You get to choose whichever one you want. When you see so you know what? As we're kind of walking through this, these are the notes that you're going to write. So I found this cute little presentation. But you're still going to write when you see. Make 2 columns. When you see, replace it with. So when you see the word what, you replace it with a variable. You could say X or A or N or whatever. Okay? You can choose whichever variable you like. Okay? That's what we're looking for. That's the unknown. When you see the word is, you can replace it with what? What does is mean? Equal sign. So the word is means put an equal sign. You can do this if you want. Next. When you see the word of, this is why I said it might not be a bad idea to use something other than X. Because this does not mean X as in the unknown. It means X as in multiplication. So maybe we'll use A's today. Okay, Nicholas? Well, I'm going to talk about that. You'll see in a minute. So the question was, when you see the word of, we do say, go ahead and put that dot, but we're dealing with decimals, right? So you kind of knew what I was going to say before I even said it. Like if I'm going to ask you to multiply 1.2 times 8, if depending on how low down your decimal is or how high up your multiplication symbol is, it might look like you wrote a number with 2 decimals. Okay? Or the decimal's a little too high. Okay? So this 1.2 times 8 is a little more, apparent. So that's why we are going to use an X for times today. Okay? But then you're going to see in a minute that even that's going to be kind of, unless we're using an A, I'll show you. So far, what number is a variable? Is equals of is times. Yeah. Does it? Yeah. And when you see a percent, you are going to replace it with what we just learned. Right? So if it says 7%, what will you write? 0.07. When you see 150%, you will replace it with 1.5. Very good. So when you see 8%, you're going to replace it with its, no apostrophe, that would be it is, its decimal form. Okay? All right. We have all the tools we need to be mathematical translators. But before we do that, here's a nice little review. Is that what your table looks like? What means X? I would suggest maybe an A, but is equals of multiplication. A percent is its decimal form. So let's practice. So looking at this, I see 40. I see the is. I see the 12%. I see the of. I see the what number. Watch. This is like, seriously, as easy as it can get. 40. There it is. Is equals 12%. There it is as a decimal. Here they decided to use the times. They did put it up kind of high. What number is the same as what? Which is X. Okay, so I want you to go ahead and write that and copy that. If you are a color coder and you would like to do that, more power to you. Still works just the same. 40. The arrows, I think, are pretty important. So I'm going to give you a minute to write that down. 40 just means write that. Is, so you see how they color match? Yeah.
Oh, it was showing page before this. It was showing it said 12, and then after it said percent. Would you?
Yeah, the 12 is the 12%.
Okay.
It would be nice if they put the actual percent symbol, which brings up a really good point. Just because it doesn't, this 12 doesn't have the percent symbol after it, like I think it could be a little trickier this way, but just know that that is 12%, okay, Alyssa?
Using the extra time, what if you do the variable?
Yeah, that's why I really wish I did not create this PowerPoint presentation, but if I did, I would tell you the variable to use would be A. Do we all agree that we want to maybe use A today instead? D, whatever you want, N for number, okay? So you can use whichever you want. Maybe I'll just use A. A seems kind of easy for that. So I don't want to confuse you, though, with two different variables. So just know that whatever you want, it's no difference. Okay, so are you okay with how we got that? There's one little thing I need to fix, though, because I've taught you in the past that means what? Which means what? It does, but it also means yes. Means 5 times the number A. Means whatever number I choose, I put it in for A and I multiply it by 5. I'm going to say A is 6. 5 times 6, 30. So, why write it like that when I can write it like that? So do you want to kind of clean this up a little bit? What do you want to change this business to? Anybody else want to maybe make that 40 equals 0.12a? Yeah? That way, you don't have to worry about using a dot or an X, do you? Did everybody see what I just did? When you multiply a coefficient, which you don't know that yet, a number times a variable, you don't need to show it with anything. You can just put the number and the variable together with nothing. So that solves our problem of do I use that or an X, right? Everybody hear that? So we're done writing the equation. All we have to do now is solve it. So watch. When you had, after you did your proportion and you cross multiplied, and you had like 30a equals 300, what did you do? You want to get a by itself, right? So you want to get rid of it, and what's the only way to get rid of it? Dividing by what's in front of it, right? Okay, and we haven't really learned that yet, but so a is going to equal what? 3/5, no, because the zeros cancel. 10. Good? Okay. So that's how you would solve that. So what should I divide both sides by? Yes, 0.12. So it cancels. I want to see that line there. 0.12. And now I'm one step away from an answer. What do I punch in first? 40. Divided by. Okay. Now, someone in third hour was pretty shocked at what the answer was. And they didn't understand how it was so big. And you know what I really liked about her question? Do you remember when I passed your quizzes out yesterday on estimating? And I said, how could, 90% of 150 kids equal 1,000 kids? Right? Remember when I said that? And I begged you to ask yourself what about your answers? Is it reasonable? So she looked at this and she said, how could you divide 40 and get a number bigger than 40?
Because it's how
Hold on. How can you, he knows it, he just wants to say it. Because usually doesn't division make your answer smaller? Right. So why is 40 divided by a number equaling 300 and something? Brian, explain it to us.
Because 12.12 is under 1.
Yes, because the number you're dividing 40 by is less than 1. I heard so many light bulbs or saw so many light bulbs go out when I did this. I don't know if you understand this, but when you're doing a division problem, what you're asking yourself is, how many times does this number fit into this number? It fits in 5 times, right? Okay, yes. So watch for a second, everybody. So we're not cleaning up binders. We're not working on anything right now except math. So everybody listen. You don't need your calculators. Put your lid on your calculator. If I take $50 and divide it by 50 cents, this means, don't shout, how many piles of 50 cents can I fit into $50? Yeah. I can fit 100, right?
Yep.
Right? Just so you believe me, 50 divided by 50 cents is 100. Which is bigger than 50. Because that was less than $1. How many quarters do you think I could fit?
100?
That was my first thought.
150?
No. 300. Well, how many can fit in $1?
400.
200. Okay. My point is, do you understand why that's bigger than that? Because that is how many can fit in. Okay. So does this answer make sense now? A is equal to 333.3 repeating. Because I can fit 333 and a little bit more piles of 12 cents into $40. Yes, James.
When you multiply that by doesn't it make it small?
Yes. So James was saying the same concept. What if I multiplied that? Usually when you multiply, you get a number bigger.
Because it's the second number is bigger.
So I multiplied 50 by something and got 6. Yeah, so very good. That's called applying what you just learned to something else. Okay, so divide both sides by 0.2. Your answer is 333.3. Ready for the next example? Why is there a thing above that 3? Somebody? Alyssa? Because it keeps going. Those 3s are never going to end. Good. Okay, example 2. Are you ready for this one? See if you can set this one up yourself using the little arrow trick. So if you are a person who likes to write in colors, then go ahead and do that. Yeah, I would use A. Just to kind of... Got it? Okay, if you think you got it written, step 2 is try to solve it. Figure out what you should do. So what number? You know that what and what number are the same, right? What and what number is 15% of 350? Starting to see some hands. Ready for the next slide? Don't look if you're not ready. Oh, I'm going to cover this up. So, what number, and if you want to use n, maybe n makes more sense for number, I don't know, is 15%, I really wish they'd have a 0 there, of, maybe you just make your x really little instead of a big X, baby X. Okay. This one's kind of different because how do I solve this one? Do I have to do any dividing? Is the variable already by itself? Yes. So what do? Just multiply. Do what it said to do. 1500 times 350. Yep. Your float, guys, if your float is set to 2, whatever pops up on your calculator for this particular problem, that's your answer. So you don't have to do any rounding right now. Your calculator rounds for you. Got it? So do you understand that? Let's just do this for the heck of it. Don't forget about the good old proportion way. Okay? Do you remember that? 15%. Here I wrote it like this. Here I'm going to write it like that. Do you remember what goes where? Of 350 is what number? We don't know yet. But I'm going to do 100 times x and get 100x. I'm going to do 15 times 300 and get 4,000.
15 times.
Oh, times, I was going to say times because my answer didn't match. 15 times 350 is 5250. That looks kind of familiar. Because when I divide by, what does dividing by 100 do? 5250. Hey, I got the same answer both ways. Raise your hand if you think you'll still kind of like the proportion way better. How many of you like the equation way? Okay. Here's the cool thing. You can use whichever one you want after this. Okay? Yeah, I want to show you one more. What do you notice about this one?
It's not one number, it's 12%.
It says what percent? What percent of 75 is 20? Okay, so let's stop for a minute. Does everybody have that written? Did anybody look at that and go, I don't like that? I don't like how that looks. What's another way to write x times 75? Yes.
75x.
Thank you. Yes. And now that it's like that and I want to get x by itself, what should I do?
75 divided by
All right, one little trick here. When I go on my calculator and take 20 divided by 75, look what pops up. 0.27. What question was I asked? What's the percent? So, should I put 0.27 as my answer? No. Joseph?
You should put 27%.
Absolutely, I should. So, because I asked you what percent, you need to see, oh, well, that popped up. I need to put that as a percent. That's my answer. Got it? Okay.